Hello. Yes. Okay. Let me just start. Very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session for the course Problem Solving Through Programming in C. This course is taught by Professor Anupam Basu from IIT Kharagpur, and what I'll be doing in this particular session that I'll be posting some of the questions based on the previous week's content in front of you all, and what you have to do, you just have to answer the questions using the chat box. Okay, this is your task. Okay, so let us just begin. Okay, no problem. The very first question for the present session is this one: which of the following are themselves a collection of different data types? Your options are a string, then structure, then char or character, or all of the above mentioned. Please do try to answer this particular question. Okay, do try to answer. Okay, then at the end we will discuss. Okay, what is the correct option and what is the correct approach? Okay, this is all what we will discuss. Okay, take your time, there is no hurry. Yes, yeah. So the correct answer to this particular question would be B, structure. Okay, as you can see yourself that option A was your string. String is essentially a collection of characters, but all characters need not to be of. But all characters are definitely of the same data type, that is char. Okay, so this is not a collection of different data types, hence it is incorrect. Okay, string won't be the correct option, but structure in C can hold multiple variables of different data types together. Okay, for example, here proper structure has been declared. Struct person having the character name as 20. Okay, int age is there, then float height is there. Okay, name, age, height are of different data types. Okay, so this is an example of structure. Okay, that is the correct option. Then comes your character, char. Character is a single character which is basic data type, not a collection at all. It would be incorrect. Okay, okay, so do try to see this. Yeah, character, a character is a single character which is a basic data type. Okay, not a collection at all. Character won't be the correct option. Okay, all of the above mentioned, this won't be correct because only structure fits in the present condition, being a collection of different data types. Okay, so all of the above won't be correct. The correct option would be your structure, because it can hold lot of variables together of different data types. Okay, string, no, it is not correct. Structure, it is correct. Character needs can hold the data type which is character only. Okay, all the data types, the variables have to be characters only. Then only the character would be able to hold. Okay, all of the above won't be correct. Correct option would be structure only, because it can only hold the variables of different data types. Okay, this is the thing. What is a structure in C? Structure in C is a user defined data type that allows you to combine variables of different types into a single unit. Okay, think of it as a custom data container where you can pack different types of data together. Okay, why we use structures? Structures we use to store the details of a student of a particular uh, data types of different category of same category. Okay, different data types of same category. When we want to store them in a particular attribute, then we use the structure. For example, if you want to store the details of a student, which are your name, roll number, then percentage, then you can use a structure that you can define by struct student. Struct is a keyword. Okay, reserved word by which you would be able to define a structure. Struct student, then character name is there. Okay, and we have provided the index as 50. Then int role is there, float percent is there. Okay, student is a template. Okay, so you can create the student records very easily. Okay, so this is the particular usage of a structure. Okay, next you see how to declare and use a structure. Okay, declaring a structure is very simple. Struct is the keyword, then you have to write the name of the structure. In this case, it is a student. Okay, then character name. After that, it is written 50. Okay, 50 in square braces means 50 number of cells have been reserved for this particular variable, which is name. Okay, then int role is there, then float percentage is there. Okay, creating a variable of this structure involves only this particular thing. You have to write start student and s1. S1 is the variable name. Okay, and student is the particular name of the structure. Okay, assigning values is very simple. You just have to use strcpy, that is a string copy. In case you want to uh, register, or you want to store a entire string, okay, then you have to use strcpy. For float values as well as integer values, directly using the assignment operator, you would be able to directly provide the values. Okay, then accessing and printing the values. Name is s1 dot name, roll number is s1 dot roll, then percent is s1 dot percent. Okay, this is the entire flow. Okay, how you can access the different data attributes from a structure? Using the dot operator. Okay, using the dot operator, you would be able to access different types of the attributes in the structure. Okay, this is the thing. Then this is a full example program. Okay, here you can see hash include stdio.h is there. Okay, this is the header file. Then string.h is there. This is another header file which we have provided. Then struct student, I have made this particular structure. Character name is there, int role is there, float percent is there. Okay, these are the different variables which I want to declare inside the structure. Okay, then it is written int main. This is the particular main function. Okay, which I have written here. int main struct student s1. I have declared a particular data attribute, a particular uh, variable of the type structure. Okay, of the type structure that I have declared, and that is s1. Okay, then I have assigned the values. Assign values. Okay, strcpy, again I have used, okay, for concatenating or copying the string the name, that is Rahul, into s1. Then I have provided the role as 101, then percent I have provided as 89.5. Then I am displaying the values using the dot operator. This dot operator you always have to keep in mind. Okay, it is not like that key you will be able to access the data stored inside the in the structure using some another parameter. Okay, just you have to use the dot operator only. Okay, so here I have printed the name, that is s1 dot name, then roll number, that is s1 dot roll, and the percentage as s1 dot percent. Okay, the key points which you should always remember is that structures let you group multiple variables of different types. Okay, and you can always access members of a structure using the dot operator. Dot operator is very very important. This you have to always keep in mind. Then you can create arrays of structures to store data for multiple records. This is very very important for you to understand. Okay, yeah, this was all regarding the structures. Answer is B, structure. Why? Because a structure in programming is composite data type that groups together variables of potentially different data types under a single name. For example, structure could hold an integer, a string, and a floating point number. Okay. Structure is typically a sequence of characters that is often implemented as an array of characters in C, which are single data type. Some of the languages, a string is treated as a single object, but is still contains a sequence of characters. Okay, which are all of the same type. Okay, it is not like that meanwhile only after declaring the data type you can change. Okay, every attribute which would be there you have to provide of the same data type. Okay, character is a primitive data type representing a single character. Okay, only structure is a composite data type that is designed to hold a collection of different data types. Okay, rest all of the options won't be correct. This is the thing. Okay, now we move to the second question. Now we move to the second question, which is which of the following comments about the usage structures is true? Okay, which of the following comments about the usage structures is true? Okay, your first option is storage class can be assigned to individual member. Okay, then comes your individual members can be initialized with a structure type declaration. C is your the scope of member name is confined to a particular structure within which it is defined, or is it D, which is none? Okay. So the following comments about the usage structures, the usage of the structures. Which of the following comments is true? Okay, this you just have to answer. Okay, do try to answer. Okay, you answered B. No, B is not correct. It is C. The scope of the member name is confined to the particular structure. The scope of the member name is confined to that particular structure within which it is defined. Okay, individual members can be initialized with a within a structure type declaration. No, it is not allowable in C. Okay, I'll go through walk you through the explanation. Okay, storage class can be assigned to individual member. No, it is not correct. Storage classes, like for example your static is there, for example your extern is there, these are used with variable functions, not with individual structure members. Okay, for example struct sample is there inside. If the structure name which you have declared, the words reserved keywords for the storage classes, for example the static is there. Okay, as well as extern is there, the usage of these particular keywords storage classes inside the structure is not allowed. Okay, hence it won't be correct. Okay, so storage class can be assigned to individual member. No, it is not correct. Okay, then comes your B part, which was individual members can be initialized within a structure type declaration. No, it is not correct. In C, it is not correct. In C++, it is correct. Okay, you can't initialize structure members inside the structure declaration. But if your language is C++, then definitely it is allowable. Okay, different languages have different syntaxes, different rules. Okay, that we have always have to abide. Okay, try to abide by them. That is the thing. Okay. So in C, you can't initialize the structure members inside the structure declaration. Okay. For example, here it is a struct example int a equal to 10. Inside the structure, I am providing the value. This is not allowed in C. Okay. Float b equal to 3.14. This is also not allowed in C. But in C++, it is allowed. Okay. Must initialize the members after declaring a structure variable like this. Struct example even, and after that I have provided in the curly braces the values which I want to assign to those particular uh, variables. Okay, this is the thing. Now you see some another aspects. The scope of the member name is confined to the particular structure within which it is defined. This is 100% correct, because this means that members inside a structure don't conflict with variables or members of the same name outside the structure in another structure. Okay. For example, int x equal to 5 is written outside the structure. Okay. Yeah, this is the same question only. This is the same question only. I am explaining you part wise. Part wise, okay? A part, B part, C part. This is the C part. I'm telling you why C part is correct, why B is not correct. Okay, this is the thing. So the scope of the variable of the member name that you try to just see here. Okay, int x equal to 5 is written. That is global variable, but it is written struct a, and inside that int x is written. This is fine because it is a separate scope. The variable x will have the scope of a local variable inside the structure. Okay, outside the structure, the variable x which I have defined, that will have a global recognition. Okay, that particular value will be used throughout the entire program. Okay, the validity of that particular variable is throughout the entire program. But whatever thing which I have declared inside the structure, that will only have the validity confined to the structure itself. Okay, that is why I have written the statement, the scope of the member name is confined to the particular structure within which it is defined. Okay, that is the thing. And D, none is not the correct option because it is incorrect. C is true, hence your option should be C. Okay, this is the thing. See here, a particular example is there. Hash include stdio.h. Then int value equal to 100 I have provided. Then I have written struct A. Inside struct A, I have provided int value. Okay. Inside another struct which is B, I have provided the float value. Okay. Then I have written int main struct A1. Okay. Inside the main function, I have provided declared two different attributes A1 and A2 of the type of the structure type A and B. Okay, then I am assigning a1 dot value equal to 10. Okay, it is not always necessary that you have to assign the values to all the data attributes, okay, which you have declared inside the structure. You can even declare one or two values, rest you can leave also. Okay, that will be automatically assigned GIGO values, garbage in garbage out. Okay, it will assign some random values. Okay, this is the thing. So here I have assigned a1 dot value equal to 10. Then I have also assigned b1 dot value equal to 3.14. Now you see I am printing the global value, which is the value. Okay. Then I am printing a1 dot value, which is a1 dot value. Okay. Same names I am using for printing these particular values. And then b1 dot value I am also trying to print. Okay. So the value, all these are values, whatever I have just declared inside the structure, that is also with the variable name value. But the scope is limited to that particular structure only. That is what I want to highlight. So here when I will be printing the global value and I have called the variable name value that I have declared just before the calling the library hash include stdio.h. Okay. So that the value would be 100. But when I am calling a1 dot value and I am printing that particular value that already I have assigned as 10. Okay. In the main function. So that will be output will be 10. Similar to that, when I am printing b1 dot value, then the output would be 3.14. Okay. So the scope of that particular variable would be valid inside the structure only. Okay. It is not like that outside the structure it would be also valid. Okay. One type of variable is the global variable, another type is the local variable. Inside the structure only the validity is there of the variables which are declared inside the structure, and these are local to that structure only. That is the crux of this particular question. Okay. There is a global value 100. Struct A and B are having their own value members. Even though they all have the same name, they don't conflict with each other because global variable is the value which lives out in the whole program, that is having the global recognition. Okay, global scope. A1 dot value and B1 dot value are only valid within their respective structures. This is what I want to highlight. Okay. Next is the correct explanation which I have provided here. Okay, in gist I have written here. Correct answer is C. The scope of the member's name is confined to that particular structure within which it is defined. Okay. Breaking down all the values, storage class can be assigned to individual member. Individual members can be initialized within a structure type declaration. This is not true. Okay. A1 is A also not is true, but the correct option is C. The scope of the member name is confined to the particular structure within which it is defined. This is the summary of all the things I have spoken till yet. You still have any doubt, then you can go through this. Okay. And the entire PDF as well as the video recordings I'll provide. Okay. Now moving to the second question, or the third question or the next question. What is actually passed if you pass a structure variable to a function? Is it the copy of structure variable? Is it the reference of the structure variable? Is it starting address of the structure variable or the ending address of the structure variable? Do try to answer. Okay. Yes, very good. You are saying copy of structure variable. Okay. Okay. Please do try to give your opinion. What is actually passed if you pass a structure variable to a function? Okay. Are copy of the state structure variable, reference of structure variable, starting address of the structure variable, or the ending address of the structure variable. Okay. Yeah, A is correct answer. I got it. Okay. Yeah. Definitely A is the correct answer. Copy of the structure variable. Okay. This is definitely correct. Why is it correct? That we just have to see. Okay. In simple terms, in C programming, when you are passing a structure variable to a function, by default, copy of the entire structure is as it is passed. This is known as pass by value. Okay. It means that any changes made inside the function will not affect the original structure, okay, which we have just declared. Okay. It's like giving someone a photocopy, okay, of your own document rather than spoiling it. Okay. Rather than spoiling the original copy, we are just providing the photocopy. Okay. This is the thing. For example, this is a particular example. Okay. Just a second. Yeah. This is a particular example. Hash include stdio.h. Then struct student is written. Then int id is written. Then float marks is written. Okay. This is the declaration of the structure. Then it is written void update. Okay. Inside the void update, what is the parameter which I am passing? That is the struct student s. Okay. The struct student s. Okay. Then it is written s.id equal to 999. Okay. This is inside of the function. Okay. So the scope of this particular statement is valid inside that particular function only. After that, I am printing inside function id, and I am printing the variable name which is s.id. Okay. Then int main is written. Inside main, it is written struct student s1 equal to 101 and 89.5, that I'm passing the as a parameter. Okay. Then it is written update s1. Okay. So original structure remains unchanged. Okay. Printf, outside the function, I am printing this particular value which is s1.id. Okay. So first of all, I am printing this particular value inside the function also, inside the structure also, and inside the main function also. And what I am values which I am getting is inside function I am getting as 999. Okay. Because this particular value I am printing inside that particular function only. But outside in the main function, if you will just try to see, I have declared struct student s1 as 101 or 89.5. Now s1.id value which I have provided through my main function, which I have provided, is 101 only. So the scope, okay, outside the function is this only, 101 only. So the value will be 101 only, because the function received a copy, not the actual s1. So modifying the s inside the function does not change the original value s1. That is the thing. If you have to modify the original value also, then you have to use the concept of pointers. You have to write down void update struct student pointer s star s. This is the asterisk mark. Okay. Then you have to write down sid equal to 999 using the pointer, and pointer you can create by hyphen and the greater than equal to greater than sign. Okay. This is the thing, using pointer to modify the original value. In this particular case, you are passing the address. Okay. So directly whatever the change which you will do to sid, that will be done to the variable itself. Okay. This is the thing. Correct answer would be copy of structure variable. Okay. Correct answer would be definitely copy of the structure variable. Okay. Because in C, when you are passing the structure variable to a function, copy of the entire structure is created and passed to the particular function. Okay. This is known as pass by value. Okay. In pass by value, a new memory allocation is allocated for the parameter which is inside the function. Values of the original structure members are copied into the new memory. Okay, that is the thing. Changes made to the structure within the function do not affect the original structure in the calling function. Okay. No referential passing is there. C does not have the concept of passing structure variables by reference. Okay. In the way which is done in some of the languages in Python and C, this particular facility is there. Okay. In Python and Java, not in C. Okay. No pointers. If you are using in the concept of pointers, okay, particularly you have to use, then you would be explicitly able to change the value which is there inside the function also. Okay, as well as a example I have created, as well as tried to provide you the conclusion, but the conclusion which is there from question number 2 and question number 3 is same only. The by default, if you are not using the pointer, the validity of the particular variable would be limited to the inside of the structure only. Whatever variable you are declaring, that would be limited inside to that particular structure only. The structure, the variable would be only having a local scope, okay, not a global scope. Okay, that is the thing. Moving to the next question, the program will allocate dash number of bytes to the PTR. Okay. For instance, you have to assume that the size of one int integer is 4. Okay. This is the question, and entire code has been provided to you. You try to answer. If you are finding any difficulty, then we'll discuss. Okay. No hard and fast rule is there. Okay. Yes, yes, yes. Please take your time. There is no hurry. Okay. Do take your time. No problem. B. Okay. Very good. Very good. That is absolutely correct, I think. Yeah. It is B only. Okay. Just a second. Yeah. The correct option would be B only. Okay. It is 8 only. Okay. As you have indicated, it is B only. Okay. 100%. Why? Let us look at the question as well as the aspects. Okay. The aspects which are associated with it. We'll just see. Yeah. For example, hash include stdio.hash has been written. This is the standard library, then a standard library. Then int main is there, int star ptr. Okay, int star ptr asterisk ptr. This declares a pointer ptr. Okay, to an integer, but it does not point to any memory yet because uh, the it is uninitialized. Okay, it's uninitialized by default. It is uninitialized. It's int star ptr by default. No memory allocation would have been there. Okay, after that it is written ptr equal to int star, then a particular function we have called, that is malloc. Okay, size of int multiplied by 4. This is multiplication, int into 4. Okay, what is this particular function which is malloc? This is in short for memory allocation. Okay, it allocates the memory dynamically from the heap. Heap means nothing but uh, the entire access of the memory which the compiler is having. Okay, the cells from minus infinity to plus infinity, that is the entire allocation from the heap. Okay, now what is happening here? Size, the proper syntax is void star. Okay, then malloc malloc in square braces only, in the round brackets only, size of the variable. Then you have to provide the size. Okay, what is happening here? Size of int is 4 bytes. Okay, size of int multiplied by 4 is 4 into 4. 4 into 4 is 16. int star. Okay, int star is used to typecast the void pointer returned by malloc to int star. Okay, now ptr is the particular pointer which is pointing to a block of memory that can hold to 4 integers in total. So ptr would be holding 4 plus 4 plus 4 plus 4. Okay, in total 16 number of bytes of memory, because it has been written ptr equal to int star malloc. Malloc is the standard memory allocation function. Then it is written size of int. Size of int already has been mentioned. It is by default 4 bytes, also mentioned in the question. So 4 into 4 is 16. So in total, using this particular syntax, 16 number of bytes are reserved for the pointer, this particular pointer. This is the meaning. Okay, now you try to see the next statement, that is ptr equal to realloc. Realloc, in the round braces it is written ptr comma size of int multiplied by 2. Okay, realloc is nothing but reallocate the memory. Okay, it is used to change the size of the memory previously allocated by the malloc, memory allocation, or the calloc. Okay, these two particular functions are there. So when the memory has to be reallocated, okay, then we use the function realloc. Okay, when it has to be freed, then we use the function free, and after that you have to write down the name of the particular pointer which you want to free. Okay, this is the thing. So realloc stands for the reallocate memory, used to change the size of the memory previously allocated by the malloc or the calloc. Okay, syntax is this particular one: void, then after that star we have to provide realloc void star ptr, that is the name of the pointer, size underscore t, then new size. Okay, this is just the variable declaration name. Okay, size t is the variable name, then new size you have to provide. Okay, that is the thing. What is happening here? The memory which was previously allocated was 4 integers, that is in total 16 bytes. Now it has shrunk only to 2 integers only, that is in total 8 bytes, because you have written size of int multiplied by 2. Okay, that is the thing. So reallocate will just reallocate the memory of 8 bytes, okay, to the pointer which is the PTR, same pointer only. It may reuse the same memory block, or it may move to the new memory or new block, or copy the first two integers. That can happen, okay. Either way, the size which will be allocated is 8 bytes only, okay. Now you try to visualize the realloc function. PTR int the two particular integer variables can be stored, okay. This is the thing. Yeah, final output is like this. The program will not produce any visible output, but it will dynamically allocate the first 16 bytes, then it will resize it to 8 number of bytes. That is the thing. Okay, this is the thing. Then you try to see here, the correct answer is B8. Okay, step by step already I have explained to you. Yeah, in the examination you will face these type of questions only, because the examination is of objective type only, okay. All the questions will be of these types only. Just the thing is, they will try to either complicate the things, or they will try to change the inputs which I have provided in the questions, okay. So only that will happen, but sooner or later, if you will watch all the sessions from week 1 to 12, as well as there is a summary session tomorrow, same time, 3 to 5, okay, then very easily you would be able to sail through, okay. That is the thing. So final memory which is allocated is 8 bytes, okay. Realloc is resizing the previously allocated block, resizing from 16 to 8. If it increases and there is space, it may extend or allocate a new block or copy the data, okay. This is the thing. Then the program will allocate 8 bytes to PTR at the end of realloc call, and the entire explanation in one slide I have provided, okay. If you still have any doubt, then feel free to go through it, okay. That is the thing. Moving to the next question, okay. Find the output of the following program. Then a particular code has been written. Very easy question, okay. Try to commit any mistake. Please do try to solve, okay. Rest we will discuss likewise, okay. Yeah. Yeah, you have answered D, okay. Good, very good, but it is not correct, okay. The correct option would be BCD, okay. I'll walk you through why is it BCD, okay. Just a second. Yeah, correct answer is BCD, okay. Step by step we will see, okay. First line was array initialization. A is a empty array, okay. A, then after that square braces is written, means the the exact size and the number of bytes I haven't provided, okay. Empty array I have provided, and I have written A as an empty bracket. Okay, then I have in the curly braces directly initialized the elements, so I need not to define the size here. That is the thing. Okay, a, then in braces, square braces, I have kept empty, means size I have kept empty, but I have provided all the elements, so size declaration here is not necessary. Okay, then it would be stored in the memory like this. Okay, always indexing in case of array will start from 0. Okay, so a, b, c, d, e, f, g, h, whatever the elements which I have provided, the indexing will start from 0 itself. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. That is the entire indexing. Okay. Afterwards, it is written character star p equal to a. Means I am defining the pointer. I am pointing this particular pointer to the array a. That is the meaning. Okay. Then it is written star plus plus p. P is pointing by default to a 0, 0th element. But plus plus p is there. Plus plus p means it is pre-increment operator. So now it will point to the first element. Okay, index first element. Earlier, when I have written character star p equal to a, would have been pointing to the element small a. But now it is pointing to the element which is b, small b. Okay, a1 element. Okay, now it is written while star p not equal to e, and it is written printf %c, then it is written star p plus plus. Okay, that is post increment. First of all, the value will be printed, then the pointer will be pointing towards the next element of the array. That is the meaning here. Okay, let us simulate this particular loop. Okay, star b equal to star p equal to b. Okay, by initially now it is pointing to b. Is b equal to e? No, b is not equal to e, hence it will be printed because it is written printf %c, and after that star p plus plus. Means first of all the value to the which the printer is pointing, okay, that value in particular would be printed. After that the pointer will point towards the next particular element. That is the meaning here. Okay. Okay, network issue is with you or with me? I don't think so it is with me because presently I'm monitoring using 3 simultaneous devices. Okay, if it is with you, then you can rejoin. Okay, I don't think so that it is with me. Oh, with me? No, no, I don't think so. Okay, is it audible to you or some issues there? Then I'll rejoin, no problem. My voice is breaking or something like that. Anything? Here I am monitoring using 2 3 devices. I don't see any flickering. Okay. So I'm assuming that everything is fine. Okay. Okay. Now it is fine. Yeah, some flickering might be there. Okay. Maybe it is with you, maybe it is with me. I cannot really understand that. Okay. Voice should be clear. Okay, that is the particular thing. Words should be clear. Okay, as well as screen should be clear. No worries about the video in general. Okay, yeah. So I was telling you about this particular thing. Let's simulating the loop. Okay, pointer by itself is pointing towards the small b. Okay, the first element. Okay, now first element will be compared if it whether it is equal to small e or not. Okay, if it is not equal to small e, okay, then the value will be printed, and it is incrementing also because it is written star b star p plus plus. Okay, star p plus plus it is written, means after one variable it is pointing towards the next variable. That is the thing here. Okay, this is the thing. So whether star p or the pointer is equal to small b, when it is equal to small b, whether it is not equal to small e, no, it is not equal to small e, so it will be printed. Similarly, it will the next element is small c. So small c is not equal to small e. Okay, it is not small e. So hence it will be also printed. Then comes the role of small d. Whether the small d is equal to small e, no, it is not equal to small e. Okay, so it is not there. But when the pointer will be pointing towards the small e is equal to small e, so it is written that inside the loop, okay, it has been written not equal to. When it is equal to, then we will come out of the loop by default. Okay, that is the thing. So b, c and d, only these three alphabets will be printed. Okay, because character star p equal to a, it is pointing towards the first character, plus p is moving to the pointer to the next character, star p plus prints the character, and then it moves towards the next character. Okay, that is the thing. Okay, so only small b, small c, small d, only these particular numerals will be printed. Okay, that is the thing. Correct answer is bcd only. Okay, tracing the execution of C code step by step, as include stdio.h is there, then entire thing is there, character A is there, then character star p is there. What is the meaning? Then plus p is there, while star p is not equal to small e. Okay, then you have to keep on printing the variables. In first iteration, it will print b, small b. Second iteration, it will print small c. In the third iteration, it will print small d. But when it will come to it is written while uh, pointer star p not equal to e. So when it will be equal to e, will come out of the loop. Okay, so output of the program will be small b, small c, small d. Okay, that is the thing. Moving towards the next question. This is the next question. Try to match the following. Okay, column A has been provided to you. Column A is Gauss-Seidel method, then Simpson's one-third rule, then Euler's method, then FEM, finite difference method. Okay, column B is numerical solution of PDEs. PDEs, partial differential equations. Okay, numerical integration is there, then initial value problems in ODEs. ODE is nothing but ordinary differential equation. Then solving systems of linear equations. Okay, try to match. Okay, try to match, then we will discuss. Okay, if some issue is there or anything is there, then we will discuss. Okay, yeah. Yes, you're given the option as A. Yeah, you are 100% correct. Correct answer is A only. Okay, let us look. Why is it A? Why is it not something else? Okay, we'll just see. Gauss-Seidel method. Gauss-Seidel method is used for solving the system of linear equations. Okay, it's just a iterative technique which is used to solve large systems of linear equations, especially sparse matrices. Okay, often used in numerical simulations involving physical systems like the ECs, electrical systems. Okay, Gauss-Seidel method is a particular method. Okay, it's a iterative technique. Iterative technique means the entire procedure has been laid out in front of you, just you have to keep on iterating till the point of time you receive the accurate desired accuracy. Okay, for example, sometimes our desire is to have an accuracy of less than 0.01. error less than 0.01. Then we keep on iterating. Okay, that is the thing. Iterative method or iterative technique means it is done in a loop. Okay, it's an iterative technique used to solve large systems of linear equations, especially the sparse matrices. Okay, often used in numerical simulations involving physical systems like the your electrical circuits is there. Okay, in those particular cases you can use the Gauss-Seidel method. Okay, then comes our Simpson's one-third rule. Okay, this is particularly used for numerical integration. It's a numerical technique which is used to approximate the value of a definite integral of a function using different parabolic segments. It is more accurate as compared to your trapezoidal rule. Okay, then comes your Euler's method. It's a method which is used for solving initial value problems. Okay, in ODEs. ODE is your ordinary differential equation. It's the simplest method which is used to solve ordinary differential equation. Okay, using an initial value. Here the equation should be of the form dy by dx equal to f of x comma y. Okay, dy by dx should be equal to f of x comma y. Okay, where your initial value we should always it should be provided to you as y x naught equal to y naught. This is the example of initial value. Okay, so Euler's method is a particular method which is used to solve initial value problems. Okay, in ODEs. ODEs is your ordinary differential equation. Okay, and the form should be dy by dx equal to f of x comma y with the particular value y x naught equal to y naught. Okay, this is the thing. Then comes your FDM, finite difference method. It is used for providing numerical solution of PDEs. PDE is nothing but partial differential equations. Okay, converts the differential equation into algebraic equations using discrete different coefficients. Okay, widely used for solving engineering problems like problems of heat flow, fluid dynamics, and PDEs, partial differential equation. These all the methods will be taught to you particularly during a particular course which is engineering mathematics 2 and as well as in engineering mathematics 3. In engineering mathematics 3 some of the numerical techniques are done dealt in great detail. Okay, while in engineering mathematics 1 and 2 it is mainly related to your matrices as well as your differential equations. Okay, all the numerical techniques and all whatever are the things. Okay, which should be there, how they should be dealt. Okay, this all are dealt. Okay, in your engineering mathematics 2 and 3. Okay, this is the thing. Next question, just try to solve. Okay, what is the output of the following C code? And a C code has been in general provided to you. Assume that the address of x is 2000 and an integer requires 4 bytes of memory. Okay, and int main is there, then unsigned int x 4 comma 3 is written inside that. An entire array has been provided to you. After that printf function is this written. This percent u is nothing but unsigned int, unsigned integer data type. Okay, then it is written x plus 3, then it is written pointer x plus 3, then it is written pointer x plus 2 plus 3. Okay, so do try to solve what shall be the correct output. Okay, this is the thing. Yeah, do try to solve. I'm just coming in 2 minutes. Okay. Yes. Yes. Now you try to see this particular question. Okay. It has been written. What is the output of the following C code? And assume the address of X is 2000 and an integer requires 4 bytes in total of the memory. Okay. That you have to see. Okay. Now you see int main is written, unsigned int x is written, 4 comma 3 is written, and everything has been written. The answer would be 2036 comma 2036 comma 2036. Why is it so? Okay, I'll just brief you about this. Okay, the question overview, if you will see, you are have been given a 2D array. Okay, unsigned int x 4 comma 3. Okay, and inside that entire array has been declared as 1 2 3 4 5 6 7 8 9 10 11 12. Okay, that has been written. So this array in total is having 4 number of rows, 3 number of columns. Okay, each element is unsigned int, which is taking 4 number of bytes. Okay, so if you try to see the memory layout, okay, which is there, it is x00. Okay, 0th row, 0th column, and the first element. Okay, that is 2000. Then after that it is 4 number of bytes are reserved. Okay, the next element will be 2004. After that it would be 2008, then 2012, then 2016, then 20, then 24, then 28, then 2032. Okay, 8 plus 4 is 32, then it is 36, then it is 40, then it is 44. Okay, this is the entire flow. Okay, memory layout. Okay, that is the thing. So each row x0, x1 is an array of 3 number of integers. Okay, 3 number of integers are there in each and every row. Okay, so each row is taking 3 into 4. Total number of bytes which are reserved is 12 bytes. Step by step analysis of the printf function. First of all, x plus 3. Okay, x is a pointer to the first row. By default, x is pointer to the first row. X has unsigned int, which is 3, third element. X plus 3 by default will be meaning go to the fourth row, which is at address 2000 plus 3 multiplied by 12, that is 2000 plus 36. In total it is 2036. So x plus 3 points to the address 2036. That is the thing here. Okay, again it is written pointer x plus 3. This is dereferencing the fourth row, that is x3. Okay, which is 10 11 and 12. So pointer x plus 3 has type unsigned int pointer pointing to x3 comma 0. So pointer x plus 3 points to the address 2036 again. Okay, now it is written pointer x plus 2 plus 3. So x plus 2 is by default pointing towards the third row. So the address is 2024. Pointer x plus 2 means pointer to the first element of the row number 2, which is 2024. So plus 3 when it will be there, pointer x plus 2 plus 3 means you move 3 integers ahead, which is 3 into 4. Total number of bytes is 12. So the new address would be 2024 plus 12, that is 2036. So pointer x plus 2 plus 3 points to the address to the 2036. Okay, final output of printf is printf %u 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 means 3 number of unsigned integers is there. Then it is written x plus 3 pointer x plus 3 pointer x plus 2 plus 3. Okay, all the three expressions point to the address 2036 itself. Okay, so the correct answer would be 2036, 2036, and 2036. Okay, that is the thing. Correct answer is 2036, 2036, 2036. Analyzing the entire C code. Okay, and whatever I have spoken till it, this has been summarized in this particular slide. Okay, if you have any doubts anywhere, then feel free to go through the PDF, which I will put in the link which has been provided to you by the NPTEL team. Okay, inside that you can go through it. Okay, this is the thing. Correct answer would be 2036, 2036, 2036 only. Okay, that is the thing. Moving to the next question. What does fe point to in the following program? The program is hash include stdio.h, int main is written, file star fp, then fp equal to f open, hello. After that, in double quotes, it is written r, then return 0 is written. Is it the first character in the file? Is it a structure which contains a character pointer which points to the first character of a file, name of the file, or last character of the file? Okay. Do try to answer. Take your time. Okay. Do try to answer. Okay. Take your time. Yeah. Actually, it would be a structure which contains a character pointer which points to the first character of a file. Okay. That would be the correct option. Okay. A structure which contains a character pointer which points to the first character of a file. In simple language, when you will use file star fp pointer fp equal to f open hello. After that, in double quotes, it is written r. What you are doing file handling, and fp is a pointer to a special structure type, which is file that contains important information about the file, which is the current position in the file, whether to read or whether to write, whether it is in read mode or whether it is in the write mode, file descriptor, as well as the buffering details. Okay. So breaking it down, what is file star fp? It's a pointer to a structure defined in the standard C library, that is stdio.h. Structure helps in C language to maintain the file internally. What happens in f open hello comma r? It opens the file named hello in read mode. Okay, that is meant by f open hello. Hello is the file which is named hello. Okay, read mode is r. Okay, yeah, returns a pointer to the file structure if it is successful. Okay, this structure has a field that is typically a character pointer that points to the first character of the file's content in memory or in file stream. Okay. Other options won't be correct. First character in the file, no, FP doesn't directly points to a character but to a structure. Name of the file won't be true. File name is just a string passed to fopen. FP doesn't point to it. Okay. Last character in the file, this also won't be correct. Okay. When opened in read mode, file pointer starts at the beginning, not in the end. Okay. So in summary, FP points to a file structure that internally contains a pointer to the file's data starting from the first character when opened in read mode. Okay. Correct answer would be B, a structure which contains a character pointer, okay, which points to the first character of a file. Breaking down the entire C code, file star represents hash include stdio.h, int main is there, file star fp is there, fp equal to f open, hello comma r, return 0. Okay. So file star fp means declares a variable name fp of type file star. File is structure type defined in stdio.h. Okay, it is used to store the information about the opened file. File star is a pointer, okay, to the file structure. Then it is written f open hello comma r, okay, in double quotes, means hello attempts to open a file named hello in the read mode, that is r. Okay, f open returns a pointer to a file structure if the file was successfully opened, null if it fails. Okay, return pointer is assigned to FP. Okay, if you still have any doubt, then feel free to go through the PDF. Okay, I'll provide the PDF. Okay, inside that this slide would be present. Okay. Now about the ninth question for the present session. Choose a correct statement about the C structure. Int main struct hello return 0. It is wrong to define an empty structure. Member variables can be added to a structure even after its first definition. There is no use of defining an empty structure. Or D, none of the above. Okay. Yeah. See here, try to see here. The correct statement about the C structure would be member variables can be added to a structure even after its first definition. First of all, this statement is absolutely true in C language. It is not true in C++. Okay, this distinction you have to understand. Okay, here how you can perform this particular operation means adding a particular member variable to a structure after its first definition. You have to uh, not only declare the member which you want to add, but you just have to redefine. Okay, from the beginning itself you have to write what are the in total all the members. Okay, once you are redefining the structure, you have to write down all the members of the particular structure once again. This is how this particular operation is performed in C language, not in C++. Okay, in C++ this is not allowed. In C only this particular facility is there. Okay, so member variables can be added to a structure even after its first definition. This particular thing is available. Okay, that is the thing. The code snippet defines an empty struct hello. Okay, we need to evaluate which statement is correct about defining or using an empty structure in C. Okay, it is wrong to define an empty structure. No, it is incorrect. In C, defining an empty structure is allowed by the C standard. However, an empty structure does not consume any memory and it has no practical value. Okay, older C compilers may issue warnings or errors, but it is generally allowed. Okay, but most of the modern compilers allow. Okay, so it is absolutely fine to define an empty structure. So hence it won't be a correct option. Next option was member variables can be added to a structure even after its first definition. This is absolutely correct. Okay, this is not incorrect. Okay, this is 100% correct. This is statement. Okay, just 1 second. Here by mistake I have written, okay, that this statement is not correct. It is absolutely correct for the C language, but not for the C++. And what is the method, how you can do it? I already have told you. Okay, this is the thing. Okay, just 1 second, guys. Okay, there is some issue. Yeah, yeah. I was explaining you this particular code snippet. Okay, struct hello, and inside that square braces is written. Okay, this is an example of empty structure. Statement number one was it is wrong to define an empty structure. This is absolutely incorrect. It is absolutely fine to define an empty structure. Then it is written member variables can be added to a structure even after its first definition. This is also 100% correct. Okay. Then it is written there is no use of defining an empty structure. No, this is incorrect. It's absolutely incorrect. Empty structure has no particular physical significance. Okay, it can still be certain niche applications, for example, as a placeholder type for generic programming or for maintaining compatibility within certain type of data formats. Can be also used for certain code behaviors, for example, as tag or in case of the markers. Okay, so it can have some physical purpose. Okay, none of the above is not correct. Okay, none of the above is not correct. Okay, just a second, I'll remove this. The only option which is correct is B only. Okay, this by mistake I have written for C++. Okay, this by mistake I have written for C++. In C++, this particular facility is not provided, but in case of C, it is absolutely provided. Okay, yeah. So do remember, correct answer would be B. It would be B. Okay, yeah. Moving towards the next question, the last question for the present session. It is written, what is the output of the following C program? Hash include stdio.h, struct T is written, then intx is written, character Y. These are the elements of the structure. Then int main is written, the struct P, P1 is written, and inside that entire elements have been declared. Okay. Then struct P star ptr 1 equal to P1. Then intx is written, which is size of P1 by 3. If statement is there, x equal to size of int plus size of character, then printf true, otherwise print false. Okay, what shall be the answer? Just have to give the answer. Okay, Yeah, the correct answer would be false only. Okay, see the code snippet I have executed, and I have found out that the correct option would be false only. Okay, why is it false? Because try to see here, hash include stdio.h is there, and instruct p is written, int x and character y are the elements of this particular structure. Then inside int main, the entire things have been written. First of all, you have to understand what is struct p. Struct p has two particular elements, int x and character y. Int x is reserving 4 typical bytes, then character y is reserving total 1 number of bytes. But there is a concept which is known as padding, okay, that already has been taught in the present week only. Okay, but due to padding is used for the alignment. Size of that struct is 8 bytes. What is why is it 8 bytes? Because there is a concept known as padding. This particular concept is there for quicker access, okay, easier access of the particular data variables. So what happens there, that for example, a structure is there which is having two different attributes or two different variables. Okay, one is having 5 number of bytes, another one is having 10 number of bytes. So whatever is the larger memory consuming structure, okay, memory consuming variable, the entire memory for quicker access will be stored in those, in the multiples of the size of that particular variable only. This is the particular in general concept of your padding. Okay, this is the concept of padding. Okay, then you initialize p1. Okay, p1 we have initialized struct p1. Okay, then the entire array has been written. This particular flat list gives the values which get interpreted in pairs. Okay, first value is int x, another one is character y. Okay, so these three values, these all the values will be stored in terms of the sets of two particular variables. So in total, three number of array would be there inside the structure P. Okay, this is the thing. Then it is written size calculation. Okay, int x equal to size of p1 divided by 3. Size of p1 gives the total size of array p1. Since there are only three number of elements of struct p, and if each is 8 bytes, so size of p1 is 3 into 8, that is 24. So x equal to 24 divided by 3. 24 by 3 is 8. Now you have to compare the x with size of int plus size of character. Size of int is 4, size of character is 1, so 4 plus 1 is in total 5. Now if x equal to 8 versus 5, okay, one side is your this particular one side is your this particular one, okay, one of the side was x equal to size of int plus size of character. So size of int plus size of character is in total 5, but x has reached to the value 8. Okay, so 8 is not equal to 5, as you already know, so final output would be false. Okay, why padding is typically 3 number of bytes, that you, if you try to understand, okay, why padding is 3 bytes only, why is it not 4 bytes or 10 number of bytes in this particular case only, specific to this particular case. Okay, int x is 4 bytes, character y is 1 byte, so total size so far is 5 number of bytes. For performance reasons, most compilers will align on world boundaries. So a 32-bit or a 64-bit system, it is usually aligned such that their size is a multiple of largest members element requirement. So in this case, it is 4 bytes. Okay. So to ensure this, the compiler adds padding after character y to align the size of the structure. It will add 3 bytes of padding after character y. Okay. So making the total size is 4 plus 1 plus 3, 3 that we have added, so that it is multiple of 4 only. 4, then 8, then 6, 12. These are the number of bytes which will the compiler will try to store. Okay, that is the thing. Visual representation of the memory layout. This alignment ensures that when you create an array of struct P, the element starts on a 4-byte boundary important for faster memory access. Okay, byte offset is 0 to 3 in case of INTX. In case of character Y, it would be in the multiples of 4. Okay, 5 to 7 is the in general padding. Okay, so 3 bytes of padding are generally added because character takes only 1 byte. Okay, but int is taking 4 number of bytes. It should be in the multiples of the largest element memory usage. Okay, that is, it should be in the multiples of 4, so it's it 8. Okay, that is the thing. So final answer is false. Okay, why is it? It is written in brief here. Whatever is the summary which I have spoken till it, that has been summarized here itself. Okay, so this particular marks the end of the present session. Thank you all for joining the session. Okay, I'll be here for a few more minutes. Okay, after that I'll leave. Okay, thank you all for joining the session. There is another session which is the summary session. Okay, that is tomorrow, Sunday, same time, 3 to 5. Okay, do join the session for the maximum benefit. Okay, yes. Thank you all. Okay. Okay, thank you all for joining the session. Do join the session next week. Okay. Not next week, tomorrow. Okay. Summary session, that would be the last session. Okay. Thank you all. I'm ending the meeting for you all, guys. Okay.